civil services aspirant. Welcome to Civil Services with ZAKI. Today we are going to discuss about the James Webb Next Generation Space Telescope. So in this video we discuss on various subtopics and basically regarding the what is James Webb Telescope and why it is considered as a next generation space telescope, and it is a most powerful and most significant telescope ever built in the history. So that's why this telescope is very significant. We also see the main instrument of the James Webb Telescope and also animation. So today's subtopic include, see here, these include a mission objectives. So what are the objectives of James Webb Telescope, and another is how Webb works, so how this telescope works, and another about the telescope, and another thing instrument of James Webb Space Telescope, and another is animation, of course, animation of James Webb Telescope, and where will Webb be? So where this James Webb Telescope will installed or situated, whether it is Earth orbit or solar orbit. It basically this is very different from the their successor Hubble telescope, because Hubble telescope orbited Earth orbit and this telescope orbited the heliocentric, basically orbit the sun, and basically this is situated and it is installed in L2 point. So what is L2 point, what is L1 point, L3 point, L4 and L5? So all we discussed in earlier video, if you remember, and if you want to more about that what is L1, L2 and L3, then you see my previous video. So that's main subtopic, and of course this topic is very significant for the civil services examination. It means we will provide you the question for the UPSC and answer of the previous question. So we move forward and see today's topic, James Webb Next Generation Telescope. So James Webb Telescope, a space telescope, sometimes called it's only JWST in short, or in short we can call it Webb, is an orbiting infrared observatory that will be a complement and extended the discovery of Hubble telescope with longer wavelength coverage and greatly improved sensitivity. So why longer wavelength is the very significant for the observing the universe and all others. So see, the longer wavelength enable Webb to look much closer to the beginning of the time. So this telescope is also called time machine, because it cover and it see beyond the 13.4 billion in the history of our universe. So and also it's hunt for the unobserved formation of the first galaxy and formation of the first star, as well as look inside the dust cloud where star and planetary system are forming today, means present day. And also if we see the James Webb is new name, but formerly previously it is known as the Next Generation Space Telescope, in short NGST. That's why it is our topic is also James Webb Next Generation Space Telescope. So previously it is called it was called as Next Generation Space Telescope, and in short we called it NGST. It was renamed in September 2000 to after the former NASA administration James Webb, or his full name is James E. Webb. Basically, James Webb was second administrator of NASA during the Apollo mission. So, as you know, Apollo mission is the great success mission, first landing on the moon by Neil Armstrong and all that. So, that's why it's dedicated the name of the James E. Webb. That's why it is called James Webb Telescope. So, we move forward and see another thing. What are the objectives of the mission? So, objective of the missions are Webb is designed to something. Number one, there are 5 objectives. Number one, observe farther into the universe than ever before. Second is search for the first star and galaxy. So, when first star and galaxy was created after Big Bang. Another third one is better understanding how planet, star, galaxy are born, evolve over the time, and what are the life cycle of these star, galaxy and all that, including our own solar system. Fourth one is explore distant world and study our own solar system. As you know, we still don't know much about our own solar system. That's why another video, if you want to see planet 9, mysterious planet of our own solar system. So astronomers believe planet 9 exists in our solar system but don't detect yet. So it may be James Webb detect this planet 9. And fifth one is determine the potential for the life on the planet around the other star, means exoplanet. It means it's also made for the search for the alien life. So that are the 5 objectives of the mission of James Webb Telescope. So we move forward and see how Webb works. So how this telescope works. So see, Webb will use infrared light which cannot perceived by the human eye to study every phase of the cosmic history. So as you know, we human only see the visible light, not infrared or ultraviolet and all other lights. So that's why we use device to detect this type of light. So the telescope, 4 scientific instruments are specifically designed to capture infrared light and will be able to peer through the cosmic dust to study colder and distant objects. So present telescope not made for the detect much colder object of the universe, but this telescope will observe the colder object of the universe. So about the telescope, so we move forward and see about the telescope. So basically Webb is the result of our 20 years of planning and development. So it is the basically hard work of the 20 years of the various scientists, astronomers and all that. Several elements make the space observatory unique and help ensure it will be meet its objective. So what are these instruments or what are these features of these telescope? So these are, see here, these are golden mirror. Webb primary mirror is 6.5 meter wide, making Webb the largest space-based telescope ever built. So that's why this topic is very significant. The mirror is made up of 18 hexagonal gold coated beryllium segment that can be adjusted individually. So we see all these hexagonal mirror in animation. So sun shield. So sun shield is another milestone and scientific achievement of this telescope itself from the basically it protect this telescope from the sun's heat, Webb will be have a tennis court size sun shield. And one of the Webb instrument will also have a refrigeration system to keep the cool, because the heat from the sun and Webb's own instrument would be otherwise interfere with the telescope observation. So another thing is deployment. So where Webb is deployed, so Webb is also a large that it will be need to fold it up like a piece of origami to fit into the Ariane 5 rocket that launch into the space. So the launching date is announced. Launching date is 31st October 2021. So that's why this is very significant, because your PT is also in October 2021. So we move forward and see instrument of James Webb Space Telescope. So see here, number one is MIRI, medium infrared instrument. So what is this? This medium or mid infrared instrument MIRI has both camera and spectrograph. Camera with spectrograph to see the light in mid infrared region of the electromagnetic spectrum with a wavelength that are longer than our eye to see. So see what this instrument will see. It's sensitive to detect, will allow the see the redshift light of distant galaxy, newly forming a star and faintly visible comet, as well as the object in our Kuiper belt, means our solar system. So another second instrument is NIRCam or NIRCam. It is basically made by NASA. So it is called NIR, means near infrared camera. It is Webb imager that will be cover the infrared wavelength from 0.6 to 5 micron. NIRCam will be detect light from the earliest star and galaxy in the process of the formation, the population of a star in the galaxy, as well as the young star in the Milky Way and Kuiper belt object, etc. So that's why this camera is very significant. Another third is NIRISS. It is from the Canada. It is Canadian instrument. So the Canadian instrument is near infrared imager and stillness spectrograph instrument will be enable the scientists to determine the composition of the planet atmosphere, observe distant galaxy, examine the object that are very close together. So basically this instrument is basically made for the see the atmosphere and the composition of the atmosphere of the exoplanet, means other solar system planet. So after that scientists will determine the and search for the alien life or alien civilization and all other things. And fourth instrument is called NIR aspects. So it is basically ESA, means European Space Agency. So the near infrared spectrograph will be operate the wavelength of 0.6 to 5 micron. A spectrograph is also sometimes called is spectrometer. It is used for the distant light from the object in a spectrum. So analyzing the spectrum of an object can tell us about its physical properties, including what is temperature, mass, chemical composition of any object of the universe. That is the all fourth major instrument installed in this James Webb Telescope. And we further move and see the another instrument called high frequency radio transmitter, and it is basically the transmitter, and this transmission received by the large radio antenna spread out around the globe, as we also discussed about these antenna. And if you see our China's Mars mission and all that, how the scientists communicate with the state, space and deep space. So this communication system is called DSN, Deep Space Network. So what is this Deep Space Network? You can see our previous video. So we can already explained all that. So this type of the waves transmitter signals and around the globe and will receive the wave transmitter and forwarded them to the Webb Science and Operations Center at the US. Basically, it is situated in the Space Telescope Science Institute at Baltimore, US. So that's all the instrument installed in the James Webb Telescope. So we also see the animation of this telescope. So see here, see the animation. So this is animation of James Webb Telescope. So see here. So first thing is the wonder is the James primary mirror. So see here, it is Hubble and it is James. So its diameter is 6.55 meter and Hubble telescope primary mirror diameter is 2.4 meter. So that's the major difference. But despite this large size of this this mirror is very lighter. This is about 113 kilogram lighter than the Hubble telescope mirror. So that is the one advantage of this. So it is lighter. So another thing, if you see the Hubble telescope, you see this type of. But if you see from the James Webb, you can see this type of image. So this is infrared. So as we know, the light and as the theory of relativity of the Einstein, the universe is expanding. So universe is expanding, it means everything is expanding, so light is also expanding. So the wavelength, like the blue wavelength or ultraviolet wavelength, is converted into the during the time into the infrared. So see here how. See here. So see. During the time it is expanding and then the wavelength is longer and longer and longer, and then it go to the infrared. So that's why James Webb detect this type of infrared. So this type of infrared and this shifting is called redshift. So if you know what is redshift and all that, we also provide you a short video series after this lecture, after this PT series. We also provide the short videos, and this short video is very significant for the all competitive examination. So we move forward and see here the animation. So how James Webb Space Telescope supposed to detect that light? So because it's primary mirror. So see here. So it catch more light. More light means more clear picture. So see here. It is made of 18 hexagonal mirror. It is. So see here. So that is the mirror. So primary mirror collect the light and send to the secondary mirror. After secondary mirror, and another mirror is the fine string mirror. So they refine the image and finally go to the instrument and call infrared detector. So see here. So basically 4 major instrument installed, as we earlier discussed in the NIRCam, NIRI and FGM and all MIRI. So all these are we see one by one. So here's here near infrared. Okay. So module A and module, and it is search for the infrared. So as we see, and this is also equipped with the chronograph. So what is chronograph? If you see something light, you cannot visible in say beyond this side of this side light. So if you stop this light, then you can visible clearly. So that type of instrument used in this James Webb Telescope, and this instrument is called chronograph. So see here, so how this works. So this light will be at, then you can clear observe this all objects. So see here, see how clear it is. So you can clear see such type of exoplanet, such type of the composition of the exoplanet. So see here, that's the another is near infrared spectroscope, and it is basically used for the spectrum and for the composition of the exoplanet or the space object, mass, temperature, and chemical composition and etc. So you see here chemical composition etc. See next. Another is near infrared imager and scatter spectrograph or NIRIS camera. So it is basically made for the exoplanet. So it can detect exoplanet far beyond our galaxy and far away galaxy. So see. Another is, if you see, it's guided by a sensor, that this type of sensor, and it is called fine guidance sensor, and in short we can call it FGS, fine guidance sensor. So despite of all that the Canadian Space Agency and NASA and basically European Space Agency, all that made by Canadian Space Agency infrared light emitter. So see this type of infrared, and after they merge and they find clear picture of the newborn galaxy and all other. So another point is to obstacle are the dust cloud. So how the scientists overcome from this dust cloud? So for this, the MIRI device installed in this James Webb Telescope. So see here, fine guidance sensor, and that is MIRI, mid infrared instrument. So this is mid infrared. So if you see mid infrared instrument is very sensitive to the heat, so it's need a very cool temperature. So it needs about 66.50 negative Celsius. So it is if we see near the 0 Kelvin, it's 6 point something 0 Kelvin, and it precisely on Celsius minus 266.5 degrees Celsius or minus 447.61 degree Fahrenheit. So for this temperature, scientists use cryocooler. So see here, cryocooler. Cryocooler basically use helium gas. So see here, scientists use here a refrigerator, like it is called cryocooler. So it is called cryocooler. Cryocooler maintain such type of temperature negative 2.6. And another something is the heat from the sun's radiation from the moons and earth. So after for these radiation James Webb Telescope equipped with the heat shield. So it is also a marvel piece of the scientific. So this basically heat shield is about a tennis court size. So see here, this is 69.5 feet long, and it is a series of 5 heat shield, and it is made by a material. It is called Captain. It is very it sustains very high temperature. So see here, this is heat. So it is this material is made from Captain, and Captain, it means it sustains very high heat. So if we see here, so that's all. It is your James Webb. So it is so big. It is so big. If we see here, the length of from here to here is a 3-story building. 3-story size of the 3-story building, and it's also a tennis court size. If we see, it is tennis court size. So it uses an origami technique to fold this telescope and fit into Ariane 5 rocket and go to the space destination in L2 point. So see here. So see here. So go to the L2 point. So see. Go to the L2. Okay, and this is here L2 point. L2 point is about 1.5 million kilometers from the Earth, and it means it is about the 9 million miles. It is 1 million miles. 1 million miles from the Earth. So if we see here, it is this distance into 4 times from Earth to the Moon. And if we see Hubble is, this is Hubble telescope, and it is only 570 kilometers from the Earth, and it is 1.5 million kilometers from the Earth. So that's why this is very, very significant, and it is free from the Earth interference and all that. And this is situated in the L2 point. So see here, 1 million miles or 1.5 million kilometer from the Earth. So here use James Webb telescope, here your Moon, here use Earth. So see. So that's all about the animation of James Webb Space Telescope. So we move forward and see another thing, where will Webb be? So where this will be installed? So at L2 point. So in addition to the orbiting Sun, Webb will be make its tight orbit around the point space known as Lagrange 2 or L2 point. So if you want to know more about L2, L3, L4 and L5, then you see my previous video. And so it's give ability to see much farther into the universe than the Hubble telescope. So another thing, Webb will be the premier observatory for the next decade, and serving thousands of astronomers worldwide. It will study every phase of the history of our universe, ranging from the first luminous glow after the Big Bang or to the formation of the solar system capable supporting of the life planet like Earth and evolution of our own solar system. That's why this is a marvelous scientific piece of the today's technology. So that's all about the James Webb Next Generation Telescope. That's why it is called Next Generation Telescope. It can be fundamentally change our understanding of the universe. So we move forward and see what are the relevance of this topic for the UPSC, and that's why it is the question for the UPSC. So, question for the UPSC. Consider the following statement. James Webb Space Telescope is an orbiting X-ray observatory. Statement 1. Statement 2. James Webb Space Telescope was formerly known as Next Generation Space Telescope. Third one is the mission objective is to search for the first star and galaxy created after the Big Bang. So, which of the above statements is correct? Your choice is A, 1 only, B, 1 and 2, C, 2 and 3, D, all of the above. Please write your answer in the comment box and don't forget to subscribe my channel and tell your friends and colleagues. And share this video in all your group. Okay, and then we move forward and see our next section. Next section is answer of the previous question. So consider the following states: Gujarat, Maharashtra, Tamil Nadu, Andhra Pradesh, Karnataka. Which of the above states are not included in the commissioned new wind energy project in 2020? So if we see, Gujarat, number 1, installed. Maharashtra is not installed. Tamil Nadu, yes, installed. Karnataka is installed. Andhra Pradesh. So Maharashtra, Andhra Pradesh and another state is MP, Madhya Pradesh, are not included in 2020 project due to some reason, because COVID-19 pandemic and all that. So your answer is 2 and 4, Andhra Pradesh and Maharashtra. So see here, A, 2 only, it is wrong. 1 and 2, it is also wrong. 2 and 3, A, 2 and 4, it is right, Maharashtra and Andhra Pradesh. 3, 4 and 5, it is also wrong. So answer is C. This is wrong, this is wrong, this is right, this is wrong. So answer is C. So that's all about James Webb Next Generation Space Telescope. So we discussed all topic regarding the James Webb Telescope. What are the instruments installed in the James Webb Telescope, and why this telescope is called Next Generation Space Telescope, and what are the technology used in James Webb Telescope, and why this telescope will very significant to understand the understanding of the universe, and basically the beginning of the universe, like the first galaxy, first star and all that. So we hope you will subscribe our channel and tell your friends, and please share this video in all your groups, whether it is WhatsApp, Telegram, Facebook, Instagram and all that. So thanks for watching this video. Thanks a lot.